Today we are going to study the chapter 6, factoring polynomials. The opposite to multiplying polynomials together is factoring polynomials. We are going to learn the 4 different ways in which we can factor polynomials. The first way will be the greatest common factor. The second method is grouping. The third, we are going to learn how to factor in trinomials where a equals 1, and the last section, trinomials where a is different to 1. And what we learned in the previous chapter when we multiplying polynomials, for example, here we had the monomial times a trinomial, and to multiply we just distribute this number through the parentheses, and we multiply 4 times 2 is 8, and x squared times x squared is x to the 4. We need to add the exponents. Positive times negative is negative. 4 times 3 is 12, and we add the exponent for x will be x to the third. Positive times positive is positive. 4 times a is 32, and we need to just x squared. Then in factoring, we will work with the same problem but backwards. Then we will start with this. We will start with the trinomial, and we want to get the factoring. We want to get the factors. This is what we are going to do in this chapter. We start from this, and we want to get how we can write these polynomials using factors. If we use the greatest common factor method, then we need to follow these steps. And we want to factor out this polynomial, this trinomial. And the step number 1 is we need to identify the greatest common factor for all the terms. And we need to identify the greatest common factor of all the terms. And we want to identify the greatest common factor of the numbers and the variables. For the numbers, we need to find the largest number that can be divided by each of the numbers. Yes, we want to find the greatest common factor of the numbers, and we want to find also the greatest common factor of the variables. Then we take any variable that are in common with each term using the lowest exponent. And this is how we can get the greatest common factor for all the terms. And let's start with the numbers. Then we want to find the greatest common factor for the numbers. Then we want to find the greatest common factor for 8, 12, and 32. Greatest common factor of 8, 12, and 32. And if you know the greatest common factor, go ahead and write just the result. But if you don't remember how to get the greatest common factor, if you don't know, then what you can do is you can list the factors for each number. For example, for A is 1, 2, 4, 8. These are the factors for 8. The factors for 12 is 1, 2, 3, 4, 6, 12. For 32 is 1, 2, 3, no, 4, 6, no, 8, 16, and 32. Then now we will find the largest number. Yes, the largest number, the largest factor. Then the largest factor will be, we had 1 is common factor, 2 is common factor, but the largest common factor is 4 because A is for A is for 32, but not for 12. Then the greatest common factor for the numbers is 4. Yes. Now for the variables, we need to check what variables are in common, and we will use in the lowest exponent. Then x is here, x is here, x is here is common. And we need to look for the lowest exponent. Then the greatest common factor of the variables will be x to the second. This is for the numbers. For the variable, let me write here, this is for the number. For the numbers, for the variable, x to the second. And we can write the greatest common factor of the polynomial is 4x squared. This is the greatest common factor of the polynomial is 4x squared. And the step number 1 is you need to find the greatest common factor of the polynomial. Then this is the part that goes in front of the parentheses. And the greatest common factor is the part that goes in front of the parentheses. And we want to write something like in front of the parentheses. Now, then we divide each term by the greatest common factor. And we divide each term of the polynomial by the greatest common factor. 4x squared, 4x squared. And the answer is what is left inside the parentheses. When we divide this one, is what is left inside the parentheses. And let's divide each term by the greatest common factor. Then 8 divided by 4 is 2. X squared divided by x to the 4 divided by x squared is x to the second. We subtract the exponents. 4 minus 2 is 2. Minus 12 divided by 4 is 3. X to the third divided by x to the second is just x. That's 3. Minus 2 is 1. 32, then positive 32 divided by 4 is 8. And x squared cancel out. Yes? Or just 2 minus 2 is 0, which is 1. Then this is the factorization of this polynomial. Yes? This is the factorization of this polynomial. And we can double check if our answer is right. If we multiply this number times this one, we should get the polynomial, in this case the trinomial. And 4 times 2 is 8. X squared times x squared is x to the 4. Positive times negative is negative. 4 times 3 is 12. X to the second times x is x. 4 times a is 32. X to the second. That is right. The factorization is right. And let's review again the procedure if we want to factor in any polynomials using the greatest common factor method. Step number 1, we need to identify the greatest common factor of all the numbers, of all the terms, the number and the variable. We need to look. We need to check both. We need to check the greatest common factor of the numbers and the variables. This is the part goes in front of the parentheses. Then we divide each term by the greatest common factor. And finally, the answer is what is left inside the parentheses. And let's try to apply this procedure to factor out these polynomials. Then the step number 1 is we need to identify the greatest common factor for the numbers and the variables. Then here is easier to identify the greatest common factor is 5. because we can divide 25 divided by 5 is 5, 15 divided by 5 is 3, 20 divided by 5 is 4. And this is the greatest common factor. For the variables, then let's write here the greatest common factor is 5. Now the variables, x to the 4, x to the third, x to the second. Let me write this one a little down. To the second. Then for the variables, x is common variable, but the lower exponent is x to the second. Then the greatest common factor equals to 5x to the second. Then we know the greatest common factor, this is the number is in front. Now to get what is left inside the parentheses, we divide each of these by the greatest common factor. And the answer is what we need to write inside the parentheses. And 25 divided by 5 is 5x. 4 minus 2 is 2. Negative 15 divided by 5 is 3. X to the third divided by x to the second is just x. 3 minus 2 is 1, but we don't need to write 1. Plus 20 divided by 5 is 4. And x cancel out. Yes, we have the same terms and they cancel out. And this is the factorization of this trinomial. Yes, and again you can double check if your answer is right. 5 times 5 is 25, x to the second times x to the second, x to the 4. 5 times 3 is negative 15, x to the second times x to the third. 5 times 4 is 20, 20, x to the second. That is right. And let's apply the same procedure for the next one. Then first we need to find the greatest common factor of the numbers. And if you know, you don't need to write the factor for each number, but let's review just in case you don't know how to find the greatest common factor. Then if you don't know the greatest common factor, this number is 4, and just you write the factors. You can write factor, list the factors is 1, 2, for 20 is 1, 2, 4, 5, for 16 is 1, 2, here I missed the 4, 1, 2, 4, 8, 16. And we can see the greatest common factor is 4. Yes? And the greatest common factor, this is 4. Now we need to check the variables. We had x to the second, x, but here there is no x. The greatest common factor is a common, then x must be in all the terms in order to be a common factor, to be part of the greatest common factor. Then x is here, but is not here, then x is not a common variable. Then in this case, the greatest common factor of the polynomial is just 4, because there is no common variable. Then now we can write 4 is in front. The greatest common factor is just 4. We divide by 4. Divide by 4. And 4 divided by 4 is 1. Then we have x to the second minus 20 divided by 4. 20 divided by 4 is 5. X plus 16 divided by 4 is 4. And if we multiply this, if we multiply these two factors, we should get the trinomial. Yeah. And this is just to say, in some cases, the greatest common factor can be just a number, okay, if there is no common variable. Then let's try the next two problems. We will do the same. Then first we need to find the greatest common factor for the numbers. We had 3, 5, 4. And we can see in this case the greatest common factor is 1. Yes, there is no any larger number. These two are prime numbers. This is 1 and 2. Then the greatest common factor is 1 for the numbers. And we can write here the greatest common factor for the numbers is 1. You don't need to write 1 if you don't want. Yes, if it's an option, but I will write just in this way. You know what is the greatest common factor for the numbers. Now, variables. We need to check the variables. We had x to the third, x to the fourth. We had x is a common variable. Then we can write here x, but the lower exponent is 1. Then we will write just x. Now let's check y. Y to the second, y to the third, y to the fourth. Then y is a common variable. We need to write y here. And 2 is the lower exponent. Is the lower exponent. Then now we need to check the last variable is z. Z is here. Is here, but it's not here. It's not a common variable. We cannot write this one in the greatest common factor because it's not a common variable. Then the greatest common factor is 1 x y to the second, or just you can write this one like x y to the second. Let me write here y in the same way. Then we know this must be in front. Then the next step is divide each third by the greatest common factor. And now we need to write what the result of each division is, what is left inside the parentheses. Then here we had 3 because it's 3 divided by 1 is 3. Now check x. 3 minus 1 is 2. Y. And if we had y to the second, they cancel out. We had the same exponent. Then now we had just z left inside for the first term. For the second one, we had 5 divided by 1 is 5. X. 3 minus 1. Sorry, 4 minus 1 is 3. Y. 3 minus 1, 3 minus 2 is 1. Then we don't need to write here. 5 minus 4. 4 divided by 1 is 4. X cancel out because we had x to the same power. But y, 2 minus y, 4 minus 2 is 2. And this is the factorization of the trinomial. This is the answer. And if you multiply the factors, yes, this one time what we had inside the parentheses, we distribute this factor to the parentheses, we should get what we had here in the problem. Then let's try the next. We had this trinomial and we want to factor out using the greatest common factor method. Then the first thing we need to find is the greatest common factor for all the terms. Then if you don't know what is the greatest common factor for the numbers, then just you can write the factors. Let's do this one just to review. Then we can write here 12. For 12 is 1, 2, 3, 4, 6, 12. 6 is 1, 2, 3, 6. For 8 is 1, 2, 4, and 8. Then we can see the greatest number that divide this number is 2. Yes. Because 4 is factor for 12 and 8, but not for 6. Then the greatest common factor of the numbers is 2. And let's check for the variables. X is common variable, then we can write x here. Now we need to find the lowest exponent. In this case will be 3. Y also is a common variable. We can write here, and then look for the lower exponent will be 2, 4, 5, then will be 2 here. And this is the greatest common factor. And we know this number, we can write this number, this number in front of the parentheses. 2x y to the second. Now we need to divide each term by the greatest common factor. 2 y to the second, 2x to the third, y to the second. Now, when we divide this, the answer is what is left inside the parentheses. Let me write this parentheses a little closer to them. Yeah. Now, 12 divided by 2 is 6. X 5 minus 3 is 2. Y to the second, they cancel out. Minus 6 divided by 2 is 3. X 4 minus 3 is 1. We don't need to write 1. Then Y 4 minus 2 is 2, plus A divided by 2 is 4. X to the third, they cancel out. Y 5 minus 2 is equals 3. Then now this is the factorization, how we can factor out this trinomial. The next method we are going to learn is how we can factor out a polynomial using the grouping method. Usually the grouping method we use if we had 4 terms in the problem. Yes, if we had, in case of greatest common factor, there is no limitation for the number of terms in the polynomial. It can be 2, 3, 4, 5, 6, 7, any number of terms in the polynomial. But in case of grouping, we usually use this method if we had 4 terms in the polynomial, 4 terms in the problem. Before to go with this one, I want just you can see the common factor. The common factor can be either a monomial or polynomial. In our previous example, the common factor was always a monomial, like in this case. Yes? And in this case, what is the common factor? We had 3, 7. Yes. Then the greatest common factor is 1, because these two numbers are prime numbers. Then the greatest common factor is 1. We say last time we don't need to write 1. And then for the variables we had x, yes, because a we had b, then just x is common variable. And in this case, the greatest common factor is x. If we just write x in front, then what is left is 3a, yes, this is left, minus 7b. If you still, you need to divide, just go ahead and divide by x, yes. Divide by x, and then you will see this cancel out, and you have 3a minus 7b. And this is how we can factor out, and the greatest common factor is just a monomial, is 1/3. But in the next example, we can see the greatest common factor can be a monomial. We had 3a times 2a plus 5b. This is one term. In the second term, we had 7b, 2a plus 5b. And we can see here, in the same way here, x, in the same way here, x is the common variable. Here, the common part is 5x plus 5b. But the common is not just one term, it's two terms. It's a polynomial. Then in the same way, we just put this one in front, yes, we write this one in front, then we can write this one in front, yes, this one goes in front. This is the part that goes in front of the parentheses. And then what we write inside is what is left. What is left? 3a, because this is a common factor. We take this one in front, and then what is left is 3a minus 7b. And we know this is the right part. This is correct, because if you multiply this one times this one, you will get the same thing we had in the problem, yes? 3a times this one equals to this one minus 7b times this one, we will get this one. Then in this case, the greatest common factor is a polynomial, it's not a monomial. Also, you can see this one. And the other way you can see this one is, if the greatest common factor is this one, then you can divide by 2a plus 5b. And you can divide here 2a plus 5b, the same we did before. This cancel out, this cancel out. Then what is left inside is 3a minus 7b. Yes? We write the greatest common factor in front, and then what is left? 3a minus 7b. Then what I want to show with this explanation is the greatest common factor can be a monomial, can be just 1/3, or can be a polynomial. Then now we will, what are the steps if we want to factor out a polynomial using the grouping method. And we will follow the steps, and we will try to factor in this polynomial. Then the first step, number 1, is we divide the problem in two parts, the first two terms and the last two terms. Then let's write here this again. Then we want to factor out this polynomial. Then let's write this one here. 10 AB plus 15B for A plus C. Then we will divide this problem in two parts. The first two, yes, and the last two. Then we divide the problem in two parts. The first two and the last two. Then what we will do in the next step is we will factor the greatest common factor for each group of the terms. Then we will get the greatest common factor for this part and this part. Then let's Now, for one moment, you need to forget and focus on the first two terms. 10ab plus 15b. Yes, just now forget the last two terms. Then what is the greatest common factor for these two terms? Then will be 10 and 15 is 5. Yes, then we need to write this one in front, is 5. We had AB, the common variable is B, then this goes in front, and then we write what left, yes? Then to get 10, we need here 2, or just 10 divided by 5 is 2. Now what is left? B cancel out, then we will have A, yes, we have A. And we know it's right because if we multiply 5 times 2 is 10, AB, we had this there. The next one will be 15 divided by 5 is 3, and B cancel out. And we know it's right because if you multiply 5 times 3 is 15, B. Yes, that is right. Now we're done with the first two terms. Yes, now we will focus in the next two terms. Then here we want to get the greatest common factor, will be 2. Yes, 2. Then what is left is 2a. 2 times 2 is 4, yes, a. And 6 divided by 2 is 3, then here must be 3. Then we need to factor the greatest common factor for this group, yes, is this part, and for the second group is this part. The terms in parentheses should match in both sides. Let's check. We had 2a plus 3, this, they match, yes, 2a plus 3, 2a plus 3. If they match, we can pull this matching greatest common factor out front. Yes, we can now, this is the greatest common factor, then we can write this one in front, 2a plus 3. And then we will put what is left inside. And if we just pull this one 2a plus 3 in front, then what is left is 5b. Yes. We pull this one out, then what is left is 5b in this case, in the second part, plus 2. Then this is the result. This is how we can write this. In terms of the factors. Then we can factor out, we can write this one like the 2a plus 3, 2a plus 3 times 5b plus 2. And now let's try to factor out this polynomial using the grouping method. And if we use, and we will follow these steps. The step number 1, we need to divide this into parts. That's the first part and the second part. Step number 2, we need to find the greatest common factor for each group. Then 32 and 40, the greatest common factor is 8. X to the second will be x, lowest exponent. Y is not common. And right here. Then now what is left? Yes. Then 32 divided by a is 4. X cancel out, and we just write y. And we know this is the right, because if you multiply 8 times 4 is 32 xy, and we get this one. This is the same. Now 40 divided by a is 5. X to the second divided by x is just x. Then we're done with the first part. Now focus in the last two terms. Then plus greatest common factor will be 3. No common variables, then just 3. 12 divided by 3 is 4. Y plus 15 divided by 3 is 5x. Now the next step is if these terms should match, and we had they match, right? This one and this one. Then pull this one in front, x, and just write inside the parentheses what is left. What is left is ax plus 3. Then if we factor out this polynomial, then the answer is 4y plus 5x ax plus 3. Then let's try this two more problems. Then we had 4 terms and we need to factor out using the grouping method. Then we divide this in 2 parts. We need to find the greatest common factor for each part. Yes. Let me do this one better. We had this part and we had this part. And in the first part, the greatest common factor will be, for numbers, will be 3. And for the variables will be x to the second. And let's see what left inside. What is left? Yes, 15 divided by 3 is 5. And x to the third divided x to the second will be just x. And it's 5x minus 3x squared divided 3x squared is 1. Yes. And just double check. 3x squared times 5x is 15x to the third. 3x squared times 1 is 3x squared. And we know this is right. That part is right. Then the next thing is, if we have negative sign, we need to be careful when we are factoring. If we have the negative term, this negative, see here, this negative, we had to be careful. We had to double check if the how we factor out is correct. And let's see first what is the greatest common factor is 5. Yes. And we can write here is, let's try negative 5. And what left inside? And 25 divided by 5 is 5, 5x. And let's write 5 divided by 5 is 1. Let's write 5 plus 1. Then now check if the sign is correctly. Then negative times positive is negative. 5 times 5x is 25x. Now negative times positive is negative times positive is negative. But here in the problem we had positive, and we need to fix that. As this sign can be not positive, should be negative. It's the only way we can get this positive. The negative times negative is positive. Another way we can double check, because usually these two terms should match, and if this is negative, this must be negative. Yes, but always just you can check, if you multiply these two terms, you must get what you had in the problem. Then negative 5 times 5x is negative 25x is correctly. And now you check negative times negative is positive. 5 times 1 is 5. Then the sign must be negative. It's the only way we can get what we had in the problem. Now these two terms, then if you had negative sign, just you had to be careful to double check always if the sign, what signs you wrote inside is correctly. Then these two terms match, then we write this one in front. What is left with inside 3x squared minus 5. And this is the solution. Yes, this is the solution. And we can write here the solution. This one is 5x plus 1, then 3x squared minus 5. Then for the last term, I add one more step here. If they don't match, means if the terms we had here don't match, we must group in another way. For example, move the second term to the end. And sometimes when we choose the first two and last two, they don't match, then in that case, you need to rearrange the terms. We had this case. And let's try to group to factor out the number, the second problem. Then what we can do, what we learn is we divide this one into groups, and we will try to get the greatest common factor for this one. Then for the numbers will be 1, yes, because 4 is no factor of 21, then it's 1. And there is no, then here the greatest common factor is 1, and you will have 4. It's the same thing. For the second one, we had 2. This is the greatest common factor for the numbers, or for the variables will be a, b. Then here, what is left is 3, 7, b. And we know this is right because if you multiply 2 times 3 is 6, ab. 2 times 7 is 14, a, b to the second. But what happened in this case if the terms don't match? Yes, that means we cannot factor out by grouping in this way. And if this happens, yes, if they don't match, then what we will do? We must group in another way. For example, move the second term to the end. And if the third terms don't match, then yes, we need to change the order and move the second term to the end. This is one option, yes, and we will just write this one. We don't change the signs of the terms. What we are doing is just we move this one to the end. This is negative 21b to the third. We will write the same term, negative 21b to the third. One thing I want you take into account is we don't change the sign. This is positive, this is positive, this is negative, and the last one is negative. Just we change the order. And now we will try to grouping again to see if this time we get matched terms. Then 4, 8 to the second plus 6ab, then the greatest common factor will be 2a. What is left is 2a plus 3b. Yes. We multiply, we get this one. The negative, the greatest common factor of 14 and 21 is 7. In this case, a is not common variable, but b is common variable. And the lowest exponent is b to the second. Then what is left will be 2. 14 divided by 7 is 2. 2a minus 21 divided by 7 is 3b. Yes, because if we multiply these two terms, 7b to the second times 3b, we will get this number. But what happened here is we had negative, we had to double check this sign. Let's see. Negative times positive is negative. And if we multiply these numbers, we will get 14ab to the second. Now we need negative here. Negative times negative is positive. But we need negative. Then we need to change this one to positive. It's the only way we can get what we had in the problem. Negative negative times positive is negative. Also, again, what the other thing with that give idea if we are doing something wrong, because these two terms should match. Then if they don't match, we need to double check our signs. And always if you have negative sign here, you just be careful, double check the signs if they are right. And now we have the right signs. Now we need these two terms, they match. Then we can write this one in front, and then this is what is left. Then we can factor out this one like 2 plus 3b, and then 2a 7b squared. This is the answer. In this section, we are going to learn how to factor trinomials. Means how to factor polynomials with 3 terms. And we will learn how to factor trinomials with this form: ax squared plus bx plus c, where a is the coefficient for x squared, b is the coefficient for x, and c is just a number. In this case, we will just learn how to factor in polynomials where a equals 1. If a equals 1, this number equals 1, well, finally we had this kind of polynomials: x squared plus bx plus c. Then before we learn, if we had these two polynomials and we multiply them using a FOIL method, yes, if we multiply them using the FOIL method, then we had the first, multiply the first, then the outside terms, the inside terms, and the last. And if we multiply using the FOIL method, we will get this one. Yes, we will get x squared minus 4x plus cx minus 24. If we combine the middle terms, then we will get x squared plus 2x minus 24. And what we will do in this section is we will solve, or we will work with the same problem but backwards. Then we start with this, and we want to get the factors. Yes, we want to get this part. Then let's see how we are going to do that. And to factor out this trinomial with this form, we will use the AC method. Then the way the AC method works is we need to find two numbers. If we multiply them, equals to a times c. When we say a times c, is the number along with x times the c. C is the last term. Yes, it's the 18. But remember, in this case, a equals 1. Then what we really want to get is, we want to get two numbers. If we multiply them, equals to c, means equals to 18. Yes, equals to 18. And if we add or subtract the same numbers, we can get the middle term. And let's try to write what this we say using words. Now we try, and we want to find two numbers. If we multiply them, equals to a times c. But in this particular case, a equals 1. Then it's just c. In our case, c equals to 18. Yes, c equals to 18. And we need to find two numbers. If we multiply them, equal to 18. And if we add or subtract them, depending on the signs, equals to 9. Now, how we are going to use these two numbers to write the factors? Then remember, we can, if we multiply the factors using FOIL, we get this answer, a similar answer. Then what we need to do is, in the factors, remember, we multiply the first terms, and the first terms always give this number. Then, because we need x squared, here must be x, and here must be x. It's the only way. If we multiply these two, we can get x squared. And x times x, x squared, this is the first the first term in FOIL method. Then now the signs. Remember, we want factors. This is we write in this way. The sign here, always this sign must be here, always. And then you multiply the signs in this way. Positive times positive, we will get this value here. It's positive. Also, the signs will be given by the numbers you had to find. Then, in either way, you can find the signs using this method, or just you find the numbers. And now we need to find these two numbers, but write just in these spaces here. Then let's see what we need to find two numbers. If we multiply them equals to 18, and if we add or subtract them, because we had both signs are positive, we know we had to add the numbers. And if we add the numbers equals to 9. Then if you know what are the numbers, just go ahead and write the numbers. Another way you can find the numbers is just you can try to find the factors for 18. Then for 18, let's try to find the prime factors. Then we can divide by 2, you will get 9. Divide by 3, or it's the same like the 3 factors. You know, you can do the same way. 3 divided by 9 divided by 3 is 3. And 3 divided by 3 is 1. Then the factors are 2, 3, and 3. And now we need to find a way how we can combine these factors to get 18. And if we add these two numbers, equals to 9. And let's, for example, try 3 and 3 and 2. Then let's see, 3 times 3 is 9 and 2. 9 times 2 is 18, but if we add these two numbers, it's 11. Then that combination doesn't work. Yes, doesn't work. Then let's try another combination. Then let's try 6 and 3. Yes, 3 times 2 is 6. 6 times 3 equals to 18. Now 6 plus 3 equals to 9. That combination works, and that is the numbers we need to write here. One is 6, other is 3. And yes, you can double check if your answer is right. Yes, you can FOIL if you want. Then x times x is x squared. 3 times x is 3x. 6 times x is 6x. 6 times 3 is 18. And x squared plus 9x, we add this, we combine the middle terms plus 18. This is exactly we had. Then this is how we can factor out this polynomial. Yes, and we can write x squared plus 9x plus 18 as x plus 6 times x plus 3. And let's try to apply this method to these different numbers. One thing is this method works only if the number or the coefficient along with the x squared or the variable that is squared is 1. For example, here you see is coefficient for a squared is 1, for x squared is 1, 1, 1. Then we can apply the AC method for this kind of trinomials. And let's see. In this case, we need to find two numbers. If we multiply them equals to 28, and if we add or subtract them equals to negative 11. And we know because this here the answer, the first term is a squared. We need something like a here. Let me write better this a here. This must be negative. Negative times positive is negative. And the numbers we need both must be negative according to this, to the numbers according to the signs we had here. Yes. And let's try to find the numbers. Then we need to find two numbers. We multiply them equals to 28. Let me write better. Let's see if I can. We need to find two numbers. Is we multiply them equals to 28. And if we add or subtract, then this, now we know by the signs we need to add two negative numbers. Equals to negative 11. And let's see what are the numbers. And again, if we don't know the numbers, if you just using your calculator, or if you know the numbers, then just go ahead and write the number. If not, then just you try to find the prime factor for 28. And you can use any method to find the factoring 3, or here is just, we will do consecutive divisions. 28 divided by 2 is 14. And we divide by 2 again will be 7. This is prime number. Yes, we divide by 7 is just 1. The prime factors are 4, 4, 7. And see what combination works. We can try to combine this 7, 2 times 2, 4 and 7. Let's try these numbers, 4 and 7. Then 4 times 7 equals to 28. 4 times 7 equals to 28. 4 times 7. And if we add negative 4, negative 7 equals to negative 11. And these are the numbers we need. Yes, we need here, sorry, here we need also the same numbers. This must be negative 7, negative 8. Yes, negative times negative is positive 28. Then the numbers must be negative. Yes, and worse, negative 4 times negative 7 is 28. Negative 4, negative 11 equal negative 4, negative 7 equals to negative 11. The numbers are negative 4, negative 7. And if you can multiply just to double check. You can multiply then using FOIL method, and you will get this. Then this is the factors we are looking for. This is the answer. Let's try the number. So we need to, then we know when the answer should be something like that. Yes. X negative is the same sign we need here, and this is negative times negative is positive. And we know the signs of the numbers will be different. Yes, one positive, the other negative. And again, this we know here is x because we need x squared here. This x times x is x squared. This sign always is the same. We need to write here. It's negative. And the next thing is we will do negative times negative and multiply the signs, and then in this case will be positive. And we need to find two numbers. If you multiply then equals to 20 to 20. And if we, in this case, we know we had to subtract the numbers. Equals to negative 8. Equal to the middle term, yes, equal to negative 8. Then if you know the numbers, just write. But the easy way is just to find the prime factors for 20. Yes, 2 is 10, divided by 2 is 5, 5 is 1. Then we can try, for example, 2 plus 2 is 4. We can try 4 and 5. And 4 times 5 is 20. But if we add then, yes, we know if both are positive, we had 4 and 5 will be 9. But we need negative 8. If we subtract then, will be 4 minus 5 will be minus 1. And it doesn't work. And we will try the other combination, 2 and 2 times 5, then 2 and 10. And we need negative 8 means 10 must be negative. And what we need is negative 10 plus 2. Yes, negative 10 plus 2 equals to negative 8. Here I missed the sign because it should be negative 20. Sorry, here it should be negative 20. Let me write correctly. Equals to negative 20. If we multiply negative 10 times 2, we will get negative 20, as this is the number we had at the end, negative 20. Then the numbers are negative 10 plus 2. Yes, we multiply negative 10 plus 2 equals to negative 20, and if we subtract negative 10 plus 2 equals to negative 8. Then the numbers are negative 10 and 2. And this is the factorization for this trinomial. And we can do the same thing for the number 3. Yes, and we know we need x here, this must be positive because this is positive, and the other is positive times negative should be negative. Then we need to find two numbers. If we multiply them equals to negative 6, and if we add or subtract them equals to 5. In this case it's subtract because we have different signs. As we know, one is positive, the other number is negative. Because 6 has, we can the factors for 6 can be 3 and 2. Yes, 3 times 2 is 6. But the numbers, we must get negative 6. And 3 minus 2, yes, signs must be different. And we can try 3 and 2. Yes, this is a prime. Yes. But what happened is, we need negative 6, so one of the numbers must be negative. And if we add or subtract the numbers, we have negative 3 plus 2 will be negative 1. Then it's now 5. The other one is minus 2 minus, sorry, 3 minus 2. 3 minus 2 is 1. And we need 5. Then these factors doesn't work. But the other way, the other factorization, yes, the other way we can get the numbers is just 6 times 1. Yes, this is 2 factors. These are also factors for 6. 6 and 1. And let's see. If we multiply the numbers, we must get negative 6. If we subtract the numbers, we should get 5. And what about 6 minus 1? Yes, 6 minus 1 equals 5, and 6 times minus 1 equals to negative 6. Then the numbers in this case, yes, sometimes we also need to try to think in another possible factors. Yes, even if we find the prime factorization, we didn't get the answer directly. Then here in this case, 6 is a positive, should write here, 1 is a negative, and this is the factorization for this trinomial. In the last case, for the last case, we will have something like x plus positive times positive is positive, and we need to find two numbers. If we multiply them equals to 6, and if we, in this case, we add them, as we know we must add because both are positive, equals to 2. Then we know the possible factors for 6 is 1, 2, 3, or 6. Yes, this is the possible factors. And let's 2 and 3. 2 times 3 is 6, but 3 plus 2 is 5. Then it doesn't work. The other possibility is 6 and 1. 6 times 1 is 6, but 6 plus 1 is 7. And also it doesn't work. Yes, it doesn't work. when this happens, when you try all the possible factors and you cannot find the number, then what is the answer in this case? That we will say it is not possible to factor the polynomial. Yes, we will say in this case it is not possible to find two numbers if we multiply them equals to 6 and if we add them equal to 2. And we will say in this case it is not possible to factor the number. And in this case, the polynomial is prime. It's prime. And it's not possible. Yes? We cannot factor out this polynomial. Also, in some cases, you need to combine two different factorization methods. And always, if you had the number in front of the variable, like in this case, always you will see if you can first factor out using the greatest common factor. In this case, we can see the greatest common factor for 3, 12, and 36 is 3. And we can write this in front, yes, and first we will use the greatest common factor to factor out this, but we need to factor out completely, yes. And if we factor out 3, we have x squared minus 4, yes, 12 divided by 3 is 4x, minus 12 divided by 3 is 12. Then now what we can see inside is we had here the trinomial, and we can use the AC method to factor out. Then let's write here we factor out using the greatest common factor, but here we know we can use the AC method, yes, to factor out what we had inside the parentheses, the trinomial. And we know this one is negative, negative times negative is positive. And here we use the AC method. And we need to find two numbers. If we multiply them equals to 12, and if we subtract the numbers equals to negative 2. Then we need to find that numbers. Let's write here equals to negative 12, and we know here we need to subtract the numbers equals to negative 4. And if you don't know the numbers, just write the numbers. If not, just find the prime factors. Then we divide by 2 will be 3 is 1. And these are the prime factors. Then we can try, for example, 6 and 2. See if this works. But we need to find negative 4. Yes, negative 4. And the only way to get negative 4 is negative 6 plus 4. Yes, negative 6 plus 2, sorry. Plus 2. Yes, 6. Negative 6 plus 2 is negative 4. And negative 6 plus 4 plus 2. Negative 6 plus 2 is negative 12. Then the numbers are 6 and 2. Yes. And this, don't forget when you move to the next step to write the 3, yes, because in this case, the factorization for this trinomial has 3 terms, 3x minus 6, x plus 2. And this is the answer. In this section, we are going to learn how to factor out trinomials where a is different of 1, is not equal to 1. Then we had trinomial like this, as 3x squared plus 11x plus 6. In this case, you see a equals 3, as the a value equals 3, then it's not equal to 1. It's not 1. Then also remember, if we have the trinomial, we will check always if we can apply first the greatest common factor and then the AC method. But clearly in this example, we cannot apply the greatest common factor, as we had 3, 11, 6, yes? And we don't have any greatest common factor in this case, or the greatest common factor is 1. Then we cannot apply this method in this case. And there is 2 different ways we can solve this problem. One is we can factor out using the grouping method, and then the AC method is the combination of these 2 methods. Or the other method is trial and error. Then because just I want to give idea about this, you will have to take this. You will have to study these topics again in Math 32. Then we will use the trial and error for this time. Then what is the trial and error? It's just we will try to get the factors thinking in the how is the FOIL method. Yes. Then remember, when we multiply the factors, if we multiply the first terms, we must get 3x squared. Then we will try to write some way we can get, if we multiply 2 terms, how we can get 3x squared. And one way is you had 3x here and x here. Then 3x times x is 3x squared. And this is one possibility. And this is one possibility. In this case, it's easier because we have 3 is a prime number. Then this is the possibility we have. 3x times x. The signs will be positive here. The same thing we did before, positive times positive is positive. And now we will guess how is the way we can get, remember the last term, how we can get the last term where we multiply this times this by FOIL. Yes, when we FOIL to get the last one, we multiply this one times this one. Then how we can get, if we multiply 2 numbers, how we can get 6? One possibility is 2 times 3. The other possibility is 6 times 1, for example. Then 2 times 3, we can try it. Yes, this is trial and error. We will try 2 and 6. 2 and 3, sorry, 2 and 3. Then this is the prime, this is the factorization, and in this case, I suggest you, if you are doing by trial and error, I suggest you just to check using the FOIL method. Then, using the FOIL method, we had 3 times x, the first, yes, will be 3x squared. Then the outside, 3x times 3 will be 9x. The inside, 2 times x is 2x. And the last one, 2 times 3 is 6. And if we combine the terms, we had 11x plus 6. And this is the trinomial we had to factor out, and this is the right answer. Okay. Then let's try the second one using the same method, yes, the trial and error method. Then we had 10x squared minus 27x plus 5. Then one way we can get the first term by FOIL can be, we need 10x squared. And one way can be 5x times 2x. 2x, yes. 5 times 2 is 10, x times x is x squared. This is one possibility. Yes, it's 5x, 5x. Then first is negative. Negative times positive is negative. And both must be negative. Then how we can get 5? Yes. The only way we can get 5 if we multiply 1 times 5. And here we don't have to worry for the signs because both are negative. Then this is 1. Either way, yes. 5. Then 5x minus 1, 2x minus 5. And now we need to multiply to see if this is the right answer. We need to FOIL. And let's see if this is the right, or if we need to maybe change 5 here and 1 at the end. Yes, let's try it. 5 times 2 is 10x squared. 5x times 5 will be negative 25x. 1 times 2 is negative 2x. Negative times negative is positive 5. And it's 10x squared minus 27x plus 5. Then we had the same thing. Then yes, this is the right factorization. If this doesn't work, yes, if here you had something different, then just you can, for example, you can change here the numbers, the order of the numbers. Probably 5 is here, 1 is here, and this is called trial and error. Yes, you will play with the numbers to see what is the right combination to get this trinomial. Let's try two more problems. Then now we had ax squared. Then one possible combination can be 4x and 2x. Yes, this is one possibility. Because 4 times 2 is a, x times x is x squared. Here is positive, here is positive. Then now we need to get 9. Yes, 9. How we can get 9? Remember, we get 9 when we multiply these two terms. Yes, 9. Then can be, for example, 3 and 3 can be one possible combination. 3 and 3. Because 3 times 3 is 9. Let's see if this combination works. If not, we need to find another way to get 9. Then 4 times 6 is 6. 4 times 2 is ax squared. 4x times 2x. 4 times 3 is 12x. 3 times 2x is 6x. 3 times 3 is 9. Then what we had here is ax squared plus 18x plus 9. That combination doesn't work because we need 22x. And what we need to do is we need to change these numbers. Yes, that numbers doesn't work. And we need to try it again. Yes, that doesn't work. Then the other way we can get 9 is 9 and 1. Yes, multiply 9 and 1. Because 9 times 1 is 9. And let's see if that combination works. 4 times 2 is 4x times 2x is ax squared. 4x times 1 is 4x. 9 times 2x is 18x. 9 times 1 is 9. And now we had ax squared plus 4 plus 8, 4x plus 18x is 22x plus 9. And this is what we want. Then this is the right factorization. Yes, this is the right one. Then now let's try the last one. Let's try the last one. We here had 2x, 4x squared minus x minus 5. Then one possibility we can write this one is, for example, 4x and x. Yes, because if we multiply 4x times x, we get 4x squared. Let's see that if that works. Negative times negative is positive. Yes. Remember, we multiply the signs negative to get positive. And now we need to get two numbers, multiply them equals to 5. Then the numbers can be, for example, 1 and 5. Yes, 1 times 5. And let's see this in this way it works. And let's FOIL. And we had 4x squared. 4x times 5 is 20x. Negative 1 times x is negative x. Negative 1 times 5 is negative 5. We combine these terms, we have negative 19, positive 19x minus 5. And we don't want 19x, we need negative x. That this doesn't work, then what we can do, because the only way to get 5 is if we multiply 1 times 5, then what we can do in this case, we switch the numbers. And maybe 5 is here and 1 is here. And we see if that works. And let's try it again. 4x times x is 4x squared. 4x times 1 is 4x. Negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. Then 4x squared. 4x minus 5x is minus x minus 5. And this is the we want. And because this is the trinomial we want to factor out, and this is right. And this is all I had for today.